All right, number 8, we're given this function f of x equals the square root of x plus 4. And we're asked to determine whether or not this is continuous at x equals -2. And if not, what type of discontinuity are we dealing with? So remember there was a 3-part test for continuity. Part 1 is, does f of c, the number that we're looking to test, does, in this case that's -2. So does f of -2 exist? So let's check it out. Let's plug that in. F of -2 is going to be equal to the square root of -2 plus 4, which is equal to the square root of 2. And that is a real number. So yes, f of -2 exists. Part 2 is, does the limit as x approaches -2 of f of x exist? All right, well let's see. So let's test some values here. So let's have x and f of x. And we want to split this up into a little table here. So we know right here at -2, this function is equal to the square root of 2. All right, so let's plug in some numbers that are very close to -2. So let's try -2.01, -2.1. On this side, maybe -1.9, -1.99. And plug those in and see what we get. So if we plugged in -2.1, well, -2.1 plus 4 is going to be 1.9. So this is the square root of 1.9. And then if we plugged in -2.01, that's going to be the square root of 1.99. And over on this side, we're going to get the square root of 2.1, the square root of 2.01. And so you can see that as we get closer and closer, as x gets closer and closer to -2, the function is getting closer and closer to a single number. And that number is -2. So yes, the limit exists. And part 3 of our test was, does the limit as x approaches -2 of f of x, does that equal f of -2? And it does. We can see that we're getting closer and closer to -2, which is what f of 2 is. So this is continuous.